Okay, so this is lesson 51, and I just wanted to introduce this lesson by solving this quadratic equation using completing the square, which is what we did in class this week. So remember, if you want to complete the square, you are going to leave a blank after the x term in your quadratic. You're going to move the 6, the constant, to the right side, and you're going to leave a blank there as well to add the same thing to both sides. The thing you're going to add is half the x coefficient. Half of 2 is 1. 1 squared is 1, so we're going to add 1 to both sides. And then we know that the left side of the equation is going to be a perfect square binomial, and that is going to be x plus half the x coefficient, which is 1. And then on the right side, we're going to have negative 5. And now, since we have a perfect square binomial on the left side, we can take the square root on both sides of the equation, remembering that we need to put plus or minus right there. And when we do that, the square on this side will disappear, and we will just end up with x plus 1 equals plus or minus the square root of negative 5. And then if we move that 1 to the right, we have negative 1 plus or minus the square root of negative 5. All right, so we were minding our own business doing this, completing the square on this perfectly normal looking quadratic equation, and suddenly we have a number that, what is it? Because square root means the number you square to get negative 5. There is no number you can square to get negative 5 in the real numbers, because when you square a number, it's always positive. If you have a negative number and you multiply it by itself, you get a positive number. You can never get a negative number when you square a number. There's no number that you can square to get negative 5. And so this lesson that's what it's about. It's about the numbers we have to work with when we end up with a negative number under the square root. All right, and these are called imaginary numbers, but like I said in class, all numbers are imaginary. All numbers are just concepts. They're an idea. It's, the idea of 3. It's just an idea. It's not something you can pick up with your hand. All the symbolic things that are algebra, these things that we're doing are invisible. They are ideas that we're working with. So learning to solve polynomial equations, like I was saying in class, is very important for the rest of the time you are taking math. You have to be able to solve quadratic equations. And so when you end up with a square root of a negative number, what are you going to do about it? What are the solutions of this equation? X squared equals negative 1. If you take the square root on both sides, you would have plus or minus the square root of negative 1, which we don't have a concept for this point. But the problem with the square root of negative 1 is that it is not part of the set of real numbers that we have worked with ever since we started out in math as little elementary school people. So the problem with square roots of negative numbers is that they don't act like real numbers. If I multiply the square root of negative 4 times the square root of negative 9, you would expect that to be positive square root of 36. But that's not what it is. The answer is negative 6. Imaginary numbers, they don't act like real numbers. They don't follow the rules of real numbers. And so somehow we have to figure out a way to make them follow the rules so that we can work with them along with the real numbers we're so used to working with. So, great human being, Swiss mathematician Leonhard Euler, who lived in the 1700s, he used the letter I and negative I for the two different square roots of negative 1. And this made us be able to actually work with these numbers along with the real numbers we're used to working with. So he said, let's let I, this letter, equal the square root of negative 1. And therefore, I squared would be negative 1 because that's what square root means. Square root means the number you square to get whatever's under that radical, in this case, negative 1. He gave us the idea that if we just deal with it this way, then we'll be able to work with real numbers as we do this. We need I so that we can force these numbers, which are outside the real numbers, to behave like real numbers. And the way we're going to do that is that whenever we see a number like b, if b is a positive real number, then the square root of negative b, we call that the square root of bi, because I is the square root of negative 1. So if we have the square root of negative b, we can change that to the square root of b times the square root of negative 1, which we are calling I. So we know that if you have something like the square root of 3 times the square root of 2, that's the same thing as the square root of 3 times 2, which is the square root of 6. But if you have the square root of 3 times the square root of negative 2, that does not equal the square root of negative 6. So you can't take this number that up to this point we're saying is meaningless and treat it like it's a real number, because it's not. What we're going to do, instead of writing it as the square root of negative 2, we're going to write it as the square root of 2i, with I on the outside, because I is the square root of negative 1. And now we've got two real numbers here. Square root of 3 times square root of 2, that's a real number. I know how to do that. Square root of 6, and then there's this I here that represents the square root of negative 1. Over here, we've got the square root of negative 3 times the square root of negative 2. And again, that does not equal the square root of 6. You cannot cancel those negative signs because these are not real numbers. They're imaginary numbers. So we have to change them to Euler's notation. So we'll call the square root of negative 3 the square root of 3i, and the square root of negative 2, we'll call that the square root of 2i. So before you do anything, when you have a problem involving a square root of a negative number, you have to use I notation. Then you can work with what you have left as a real number. So you can rearrange this because multiplication is commutative. So square root of 3 times square root of 2 times I. So that's the square root of 6i squared. And what is I squared? If I is the square root of negative 1, then if you square it, you get negative 1. So this is negative 1. So square root of 6 times negative 1 is equal to negative square root of 6. So again, you want to write these things using Euler's notation. The square root of negative 13 is the square root of positive 13 times I, the square root of negative 1. The square root of negative 4 is the square root of positive 4 times I, which is 2i. The square root of 3 times the square root of negative 2, we just did, so I'm not going to do it again. Okay, so all numbers which are of the form a plus bi, where a and b are real numbers, belong to the set of what we call the complex numbers. The standard form for writing a complex number is to write the real part first and the imaginary part second. And that is how you have to write them, where a is the real part, b is the imaginary part. All right, so these are now all the numbers that you've worked with since you started doing math. All right, we started out with the counting numbers when you were very small. And those numbers, if I can find my pen, there it is. The counting numbers are just the numbers you use when you count. 1, 2, 3, 4, and so on. The whole numbers is that same set of numbers, except you add 0 to it. Those are called the whole numbers. The integers are the positive and negative whole numbers. Rational numbers, they are the numbers that can be written as fractions with an integer in the numerator and in the denominator. So those are the rational numbers. The irrational numbers are the numbers that cannot be written as a fraction with an integer in the numerator and the denominator. These are numbers like the square root of 2, pi, negative square root of 5, and so on. These are numbers that you cannot write any other way except the way you see them right here, because they are non-repeating, non-terminating decimals, and they cannot be written as a fraction, so there's no other way to write them. All right, and now we have added this set of complex numbers. We have the imaginary numbers, which is a part of the complex numbers. Those are the numbers that just have an imaginary part. Negative I, pi times I. And then we have the numbers that have a real part, like this, and an imaginary part. So all those numbers belong to the complex numbers, and all the numbers we've dealt with since elementary school are inside that set as well, because any real number can just be written as, you could write 1 as 1 plus 0i. So it's still part of the complex numbers. All those numbers right there all belong to this bigger set called the complex numbers. And from now on, you will be working with that extra part of the set that we hadn't worked with before. So I is the number, the square root of -1. So if I is the square root of -1, that means that I squared is -1. So what we're going to do in this problem here is we're just going to group our i's in groups of 2 so that we'll have I squared and we can exchange those for -1. So here you have 2 i's, so that's 2i squared minus, and then you've got 3i cubed, so you've got 2 i's right there. I'm going to call those I squared, and then you have 1 I left over, so I'm just going to put that there. Okay, and then plus 2i minus 4 minus, now you have the square root of -4. When you have the square root of a negative number, you just rewrite it with a positive number, and then you put the I on the outside. Pay close attention to the fact that I did not cancel these negative signs. That is not something you could do. The negative sign on the outside has nothing to do with the negative sign on the inside. They do not come into contact with each other at all. All right, so we can simplify this now by everywhere we see an I squared, we will put -1. Square root of 4 is 2, so 2i. So I have a positive 2i and a negative 2i. I can cancel those out. I have -2 plus 3i and then minus 4. So -2 minus 4 is -6, and then plus 3i. And you can see that I put the real number first and the imaginary number second. Okay, on this last one, we have the same situation. We have 3i cubed. I could write that, since it's I can write it as 3i squared times I. And remember, when you multiply like bases, you add the exponents. So I squared times I to the first is I to the 2 plus 1, or 3. We're just grouping the i's together in groups of 2 so that we know each group of 2 is -1 when you're multiplying I times I. So here we've got 2, and we can go ahead and put -1 where we see that I squared. I squared is -1. And then we've got 7i and 4. And over here we have 2i to the 5th. So that's I times I, 5 times. All right, so every 2 of those is going to give us a -1. So we're going to rewrite that as 2i squared times I squared. And then there's one more I left over. So I'm going to change all these I squareds into -1s. So 2 times -1 times -1 times I. So we've got -3i minus 2 plus 7i plus 4 plus 2i. And so if I add up all my real numbers, -2 plus 4, that's 2. And if I add up my imaginary numbers, I've got -3i, 7, and 2. That's 9 minus 3 is 6. So plus 6i.